Okay, welcome back. We are going to page 35 in your textbook, and we're talking about item number 3 on tonight's homework. This time, a rectangle has side lengths S and 2S. So for example, it could look like this, S and 2S. Mine is clearly not to scale. It says its area is represented by the expression 2S squared. The area of the rectangle is a function of its side length. Guys, this means that the length of the side does have a relationship to the area. But as we talked about earlier, when we are finding the area, is area by nature a linear measurement? Yes or no? No. So whenever they say the length of the side is a function as it relates to the area, does this describe a linear or nonlinear function? You will always say nonlinear whenever they're taking a linear measurement and using it to get something that would not be measured in a line. Now, in regard to a rectangle, what would be measured in a line? The what of the rectangle? Say it. Perimeter. But if they are saying you're now going to measure the area, is that a singular dimension? No. Is area represented by a singular line ever? No. So non-linear. And then they make it easy for you guys. Then they show you a grid. What about the graph with the gridded items helps you know it is non-linear? Please tell me, Kenley. It's not a straight line. Wave if you understand how you can tell that this situation represents a non-linear function in multiple ways. All right, continue videoing because I need to talk about this one. Now they want you to use the strategy of, are there changes that are consistent? Guys, you remember before we did changes in Y, that looks like chinny. We did changes in Y over changes in what?
X.
In X. Now what do you remember? It is constant if the changes in Y over changes in X keep giving you the same number, right? Okay, so on your textbook right now, let's go to the changes in Y. Is that the first column or the second column, guys? Second column. But to get from 25 to 45, will you add or subtract something? So please draw an arrow like you see on my screen, and please put plus, how much to add? 20. So plus 20. Go from your X value at the top that matches 25 and draw your arrow down to your second X value that is across from 45. What do you add on the X side? 1. So far, I have a change in Y of 20, a change in X of 1. Now I'm going to write changes in Y over changes in X for the next two comparisons. How much am I adding from 45 to 60? Say it if you know.
15.
It is not 20, it is not 25, it is what?
15.
I'll help, good, it's 15. I'll help you by counting on. If you go 45 up to 50, how many spaces have you gone? 5. And then how many spaces from 50 to 60? 10. Smush them together, you get plus what? Say it again. 15. How many spaces from 2 to 3? 1. Class, write your changes in Y over changes in X. What did you just now write, Ridge? Changes in Y over changes in X. What are you writing now? Sweetie, we just wrote changes in Y and we just wrote changes in X. Remember, these are changes in Y, or this is the last one that we wrote, and that's the last one that we wrote for changes in X. Please tell me what I will write as my changes in Y over changes in X. Yeah. Okay, you have the correct numbers. Great job with the correct numbers. However, remember this. Where do the changes in Y belong? In numerator or denominator? Good. The 15 belongs in the numerator. Class, wave if you also correctly put 15 in your numerator. Okay, and then finish, Ridge, what goes in the denominator? All right, everybody look at this. Do the changes in Y over changes in X stay constant, yes or no?
I mean,
Well,
no,
this is 20 over 1 and this is 15 over 1.
No.
So I'm thinking And if the answer is no, then what letters will we use to represent what it is? L for linear and L for nonlinear. Class, what will you write? I hope you are writing NL. Changes in Y over changes in X, when they do not stay the same, it is what? Nonlinear. Okay, let's quickly go and keep filming, please. We're going to do number 5. Guys, what is my change in Y right here from 2.2 to 4.4? Call it out.
2.22.
Excellent. What is my change in X from 15 to 30? Say it. 15. Excellent. And then tell me, please, what are my changes in Y for the second two?
2.2.
Oh, also 2.2. And what are my changes in X?
Oh my God. 15.
Oh, also 15. So what does this let us know, Finn? Is it linear or non-linear? Excellent. Class, write a giant L. Not for loser, just for linear. All right, keep it going because there's one more thing I want to show you guys about the back. Number 8, Catalina and Terry are each saving money to buy a car. Catalina puts $1,000, ooh, that's a bunch of money, $1,000 in a safe at home and adds $25 every month. Class, write the number story of what this is expressing right here. So are you writing 1,000 as your constant? Are you writing plus 25 per M representing month? Yes. So ask yourself, does that appear to be a linear expression?
Yeah.
Yes, it doesn't break any of the rules, does it? Okay, so now let's analyze. Terry puts $500 in a savings account at the bank. Oh, so what is the constant for that situation?
500.
500. And then it earns 3.2% interest each month on the total amount of money in the account. So it would be plus, oh my gosh, that first month, it would be 3.2% of 500, right?
Yeah.
But then the next month, it would be 3.2% of the previous month. Okay, so even though you don't know what numbers to write there, can you agree that this is not going to represent a constant change, is it?
Yeah.
Because isn't 3.2% of something greater than 500 going to be a different amount than 3.2% of 500?
Yeah.
So each month, the amount they earn in interest will grow what we call exponentially. Because of this, who is showing a linear function? Which of these is a linear function? Catalina's or Terry's? Say it, class.
Catalina.
Catalina's is the linear function. Do you understand how to tell the difference in a word problem? Okay, last one, number 9. Volume of a cube is a function of its what? Side length. Is a side length a linear function? Yes. But it says the volume of a cube. So similarly, the surface area of a cube is a function of its side length. Surface area is a function of its side length. Which of these relationships is a linear function? Construct an argument to justify your response. Now, I taught you thoroughly at the beginning of this class. If it can be measured still in the length of a rope, represented as a line, you say yes, linear. Can the volume of a cube be represented by a rope or by a line?
Yes.
No, so it's non-linear. Can the area of a cube be represented by a rope or by a line only? No. Aha. So this is one of those tricky questions. What do you think the answer will be? Raise your hand if you'd like to tell me. It's one of those tricky ones, Justin.
Non-linear.
Yes, but what did they say? Which of these relationships is a linear function? So what will your answer be?
None.
None or neither. Either answer is correct. You may stop filming.